Hello everyone, and welcome to the Mat 211 review of Measures of Central Tendency. My name is Julia, and I work for the tutoring centers at ASU. So, we want to determine the expected value given by the following probability distribution, where we have our x's, 1, 2, 3, 4, and 5, and the associated probabilities with them. So let's make this a little x so that it's a little more clear that these are the values that are going to be going into this x here. Now, so let's first talk about what expected value is. We often denote expected value as e to the x, big X here, or sometimes you'll also see it written as e to the bracket x. Either is the same, it's just different notation, but we'll go ahead and use the form with parentheses. So expected value is found by taking the sum of each pair of little x values, so that would be our 1, 2, 3, 4, 5, and so on, and timesing it by the probability of getting to each of those values, so where your big X is equal to this little x value. So that would be, we'd have the 1 times 2.5 here, plus 2 times 0.2 here, and so on. So we can write this in the notation e to the x, or the expected value of x, is equal to the sum from I equals 1 to n, where n is our number of different outcomes, our number of different values for our little x. And so we're taking the sum of each little x, which we'll denote as little xi here, times the probability of big X being that little x value. So in our case, we know that n is going to be 5 because we have 1, 2, 3, 4, 5 different values that little x can take. So we want to go through and multiply each of these values that little x can take by its associated probability, and then we're just going to add those all up. So this looks like 1 times 0.25 plus 2 times 0.2 plus 3 times 0.2 plus 4 times 2.5, or 0.25, and then plus 5 times 0.1. Now, if we go and do our products first here, we'll have 0.25 for our first, plus 0.4, which is 2 times 0.2, plus 0.6, plus 1, that's 4 times 0.25, plus 0.5. And if we go ahead and add these all up, we get 2.75. And this is the expected value of our big X. So note that this value is not found in our outcomes for little x, or the possible values that big X can take. That's okay. A lot of times that will happen where you have a value for the expected value of x, which is different than the possible values that big X can take. All this means is that this is kind of a weighted mean, where we're weighting based on the probabilities of each different value that x can take. So it's totally okay to find a value that's not in our range. That can still be an expected value. So that's it. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring for your specific course, you can use our tutor search tool, which you can find off of our main website here, or by going directly to the tool at this full link on the screen. So thanks so much, and have a great rest of your day.